Good afternoon, everybody. What are writing, master? Was any unchecked work left? All yeah, thanks. All completed. When was it checked last time? 26. 26 means only one work left. What is the format? Make format. New work, new format. Remember. Okay, every time remember. Okay. Which chapter are we in? Chapter 14, right? Classification of elements. And I have already told you we have to complete up to which chapter? 16. Two more chapters left. One is chemical reaction. Otherwise, no problem. And okay, today, now homework. Today's homework is like this. So, group leaders will stand up. Heisenberg, I remember when I see Jay, and you, Whittaker, okay, only two, and you, Mendeleev, you, Newton, you, Einstein, okay. So five groups are there. So they have to make 5 sets of new questions and submit. 5 sets, okay, different sets. Understood or not? Do you know the pattern? Okay, sit down. Do you know pattern or not? MCQ, how much marks? 10 marks. MCQ 10 marks. Very short questions, 9 marks. Short questions, 28 marks. Long questions also, 28 marks. Altogether, 75 marks. That is the pattern. It must come by Tuesday, not tomorrow. Tomorrow I am not going to ask you. When you submit, tomorrow question must come. And syllabus is chapter 1 to chapter 14. From chapter 1 to chapter 14. You have to make that question in Word only, Microsoft Word. Don't make that in PowerPoint or PDF. And your long questions must be from diagrammatic questions. In book, are there diagrammatic questions? Or not? So from there you have to make. Now the leader, you divide the work into your friends, because each member there are four members. Each group there are four members, and 4 questions, 4 groups are there. Group A, Group B, Group C, Group D. I mean Group A, MCQ, Group B, VSQ, Group C, SQ, Group D, LQ, and you combine and send. Only 5 email must come. From each group, only 1 email, but the group leader must collect and submit. Understood? So Tuesday, when you submit? Tuesday. Next one is now presentation from which group? Which group presentation is there? Or chapter completed? Then okay. Now at first, Lisa, which group you belong to? Albert Einstein. From Albert Einstein, there is presentation as first, and afterwards, which presentation is there? Whittaker? Yours? Okay. Then chapter over? Yeah. Now first, who's done? The last time up to where it was done? We can see here also. Last time up to where it was done. Grade 10. Did you find, children? We have discussed up to groups and periods. Sarnia, she has done up to these 2 characteristics of groups, right? Now Sarnia, come in. Okay, now who's turn? Nilisa turn. Nilisa, come in. No, Mendel, who is Mendel? Bians? Bians, come. Bians, come here. Okay, first his turn, and after this one, page number 320, 21, 22. Who's turn? Go outside. No, not let me go.
I have not prepared. They have prepared.
No, who are we the group leader? Then your duty is that one, come here. Whom you have given duty, come here. Yeah, who prepared it?
I think they prepared, sir.
Oh.
What do you do? You have not said to anyone. We have not discussed.
Previous time I
have said to discuss.
Then after I have done. Then
I have done. I have also done.
Yes, I have also.
Last time,
Then last time
CC performed then.
Then Previous after then I have previous, sir.
Yeah.
Nobody.
I mean, nobody who are the members. Hey, where
Susan
did you-
and Ronnie, sir.
Where's
We
Susan?
have
Susan is
also
where is it?
done before me.
Before you. And Susan, where is your work?
Not done.
Your work?
Not
See?
yet.
Sit together. Which group you belong to? Find out your group.
Yes.
You go there. You two girls go there side. Susan, come here. Susan, come here. Which again?
Good afternoon, everyone. I'm Suresh Gurung, standing in front of you to explain about the Gaussian chapter classification of elements. So first, Whittaker. Robert Harding Whittaker was an American plant ecologist active from the 90s to the 1970s. He was the first to propose the five kingdom taxonomic classification of the world biota into the Animalia, Plantae, Fungi, Protista, and Monera in 1969. Non-metals. Non-metals are placed on the right side of the zigzag line in the periodic table. Non-metals are found in group 5, 6, 7, and 18. They are bad conductor of heat and electricity. They have tendency to gain electrons to form a negative ion. There are 22 non-metals. Out of them, 11 are found in gaseous states. So, so as you all know, first non-metals are bad conductor of heat and electricity, and they have tendency to gain electrons to form negative ion, and there are known to be 22 non-metals. Out of them are 11. Those are found in gaseous states, and non-metal are placed on the right side of the zigzag line in the periodic table, as you can see here. The non-metal. This is the non-metals, and yes. Group 16, chalcogene. The elements of this group are oxygen O, sulfur S, selenium Se, tellurium Te, and polonium Po. They have six valence electrons. They gain two electrons to form two negative ions. The electronic configuration of the valence shell of non-metal is represented by Nb power 1, where N denotes shell, and for example oxygen O, whose electronic configuration is one small power 2 and two small power 2 and 2p4, and these elements are also termed as chalcogenes. Chalcose meaning copper, because these elements are found in combined with copper in nature and form copper ore. So first word, the elements of this group are oxygen, sulfur, selenium, tellurium, and polonium, and they have six valence electrons, and they gain two electrons to form two negative ions also, and the electronic configuration of the valence shell of non-metal is represented by Np power 1, where N denotes shell, and for example oxygen O, whose configuration is 1s2 and 2 2 2s2 and 2p4. And chalcose meaning copper because these elements are found combined with copper in nature to form copper ore. Group 17, halogens. The elements of this group are fluorine, chlorine, and bromine, iodine, and acetylene. They have 7 valence electrons. They gain 1 electron to form negative ion. These elements are called halogens because they form salt with metals. These elements are highly toxic in high concentration. They are highly reactive. The elements of this group are soft with low density. The electronic configuration of the valence shell of non-metal is represented by Ns power 3 and Np5. So, the elements of this group are fluorine, chlorine, bromine, iodine, and acetylene. As you can see here also, it is in the figure, and it also lies in here. So, they have 7 valence electrons, first of all, and they gain 1 electron to form a negative ion, and these elements are called halogen because they form salts with metals, and these elements are highly toxic in high concentration, and they are very highly reactive, and the elements of the group are soft with low density, and the electronic configuration of the valence shell of non-metals is given by NS3 and Np5. Group 18, noble gases. So, the elements belonging to the group 18 are helium, helium He, neon Ne, and argon Ar, krypton Kr, xenon Xe, and radon Rn. As you can know, it lies over here in the periodic table, and except in helium, all these elements have 8 electrons, 8 electrons, and they have 8 electrons in their valence shell, and therefore complete octet and stable. These elements are placed on the extreme right of the periodic table, and it is right here.
Lovely.
Halogens. As you can see in the figure, these are the elements that we present in halogens, and in noble gases these are presented. Metalloids. So first of all, metalloids are good and bad conductor of heat and electricity. Good and bad. So, metalloids found along the zigzag line between metal and non-metal exhibit the characteristics of metals and non-metals. Both elements like boron, silicon, germanium, arsenic, antimony, tellurium, and polonium are metalloids spanning from group 13 to group 16. First, some metalloids, they are boron, silicon, germanium, and arsenic, antimony, tellurium, and polonium are metalloids, and metalloids found along zigzag line between metals and non-metal. It is right here, as you can see in the figure. Metalloids are right in the between of metals and non-metals. Next one. Reactivity of metal. Reactivity of metal. The reactivity of metal indicates how fast the reaction occurs, and metal takes electron easily, highly reactive, cause a fast reaction. The greater the speed of the reaction, the more vigorous and dangerous the result. Such reaction involving high reactive metals can be vigorous, explosive, and dangerous. So, as you can see in the figure also, from the least reactive to the most reactive, uh, reactivity series of metals are shown here, and they are very, the most reactive are very highly reactive because of a fast because metals that lose electron easily cause a fast reaction, and yes. And such reaction involving high reactive metals can be vigorous, explosive, and dangerous. Reactivity of non-metals. The elements of group 15, 16, and 17 are non-metals. As we move from top to bottom in a group of non-metals, the atomic size increases with the addition of the number of cells, and the force of attraction between the nucleus and valence shell decreases. The force of attraction between the nucleus and valence electrons of smaller atom mass is more than that of the bigger atoms. Due to this, the smaller atoms S can gain valence electron more easily, with more force of attraction than the bigger atom S. So, first of all, why is potassium more reactive than sodium? Both potassium and sodium are alkali metals which belong to group 1 in the periodic table. Both of them contain one valence electron. Since the atomic size of potassium is bigger than the atomic size of sodium, the force of attraction between the nucleus and valence shell of potassium is less than that of sodium. So potassium loses its valence electron more easily than sodium. Hence, the potassium is highly reactive compared to the sodium. So both of them contain one valence electron, and since the atom size of potassium is bigger than the atomic size of sodium, the force of attraction between the nucleus and the valence shell of potassium is less than that of sodium. So potassium loses its valence more easily than sodium, and
Okay, now remaining will be said next time. Okay. Our time it will be. Thank you very much. So actually, our hero has said many more things. We will discuss minor thing and then complete it. Will class 10 is here, right? So Here we have to remember position of elements in periodic table. Position of elements, like what do you call the elements which are kept in group 1A, group 2A, group 6A, subgroup B, and group 18? You sit correctly. Why are you bending your body? Okay. So one whole portion is left that should be done by the group tomorrow. I'll just tell you about here. Groups, periods, metals, metalloids. Okay. Position of different type of elements in the modern periodic table. Where is hydrogen kept in modern periodic table? Hydrogen is kept in group IA or simply in group 1. Still, the position of hydrogen is not correct because it is non-metal, but it is kept in the group of metals. Actually, we say Rahu and Ketu. Rahu, that was Asur, but nowadays he got the position of Devta because he got chance to have Amrit. Yes or no? In the same way, hydrogen is non-metal, but it got chance to sit with metal. Why? Because in the outermost orbit, there is only one electron. Its electronic configuration is 1s1. At last there is s1. At last there is s1. Like lithium, 1s2, 2s1. Like sodium, this is lithium. Eh? Sodium, 1s2, 2s2, 2p6, 3s1. At last S1 is there or not? How S1 came, that will be discussed later on too. Don't worry, that is electronic configuration. So hydrogen is kept in group 1 due to lowest atomic number and only one electron in valence shell. Representative elements. Representative elements means those elements which do not have variable valency. They have got same valency, only one valency. We have discussed about valency. Valency means combining capacity of elements. Some elements they have got fixed valency, only one valency. Some they have got two valency also. Like gold. Gold has got two valency. One is either 1 or 3. Silver 1 only. Next one, lead, LEAD, lead. It has got two valency, 2 or 4. Manganese, 2 or 4. It comes like that. Iron, 2 or 3. Okay. Copper, 1 or 2. So representative elements mean those elements which are kept in. Where are they kept? 1A. Where? In 1. Why it's not coming? 1A to 7A and group 18 or 0. Those elements which are kept in group 1A to 7A, 1A to 7A I have mentioned, and they are at last, their last orbital is p orbital. Their orbital is p. At last p comes there. They are representative elements. So next one is you have just said metals. Where are the metals kept? Metals are kept in left hand side. Non-metals are kept in right hand side. Metalloids. Where are the metalloids kept? Between metals and non-metals. Next one, alkali metals. What do you remember here? Alkali metals. What do you mean by alkali metals? Alkali metals means those metals which react with oxygen and they can form alkali with water, or their oxides are soluble in water. Or we can say alkali metals are those metals which can form alkali, strong alkali. For example, let me check here the periodic table. There was presentation in periodic table. Where is the presentation? Okay, just sometimes this net become a bit slow. Yeah. Thank you comes directly without showing predictable thank you. But why Simres? The group, the second A elements, these are called alkaline earth metals. Alkaline earth metals means they are found on earth crust. Where are they found? And they also can form alkali. So alkali, we just remember, right? If I write here NaOH, this is alkali, sodium hydroxide. Next one, KOH, potassium hydroxide. Then CaOH whole 2, calcium hydroxide. These are alkalis, for example, right? Next one, he brought here group 6A elements. This one. What are they called? Chalcogenes. What do you call them? Why are they called chalcogenes? Because they are found combined with copper. They are found combined with copper. They are copper compounds. Elements of groups, this one, 7A. 7A. They are called halogens. What do you call them? Halogen means they react with metal and form salt. They are salt makers. Halogens means they can form salt. What are the examples of halogens? Fluorine, chlorine, bromine, iodine. Mainly these four you have to remember, right? And these last elements, He, Ne, Ar, Kr, Xen, noble gases or inert gases. Why are they inert? Because they do not take part in chemical reaction. Their outermost shell is full of electrons. They neither take nor lose. Right? No gain, no loss. So they are very passive. They are called inert gases. What do you call them? Inert gases. Then here are some elements. These are metalloids. What are the examples of metalloids? Boron, silicon, germanium, arsenic, strontium, tellurium, polonium. These are, what are they? Metalloids. Why are they called metalloids? They contain the characteristics of both metals and non-metals. Both characteristics are there. And these, rest of other, these all elements are called non-metals. They are poor conductor of electricity, heat, and they gain electron if they take part in chemical reaction. In that way, we have to remember. Okay. Now, next part is there, like why potassium is more reactive, why fluorine is more reactive. Like here is the potassium, here is sodium. In between potassium, sodium, which one is more reactive? In between magnesium and calcium, which one is more reactive? That will be discussed in our next video. Is that okay? Please give a glance upon the chapter. BSQ 9 marks, 9 questions. SQ 28 marks, 14 questions. And I think principles are maybe there. So these should I say there? Okay, let's take in there and give them. Otherwise, our next one. So next one is what is that? Long questions, 28 marks, 7 questions. Understood or not? Do you know the pattern or not? Already? Accordingly, you prepare and submit. Okay?
One set of questions.
Sorry? Right?
Sir, chapters up to
Chapter 13. Chapter 1 to chapter 13. Very simple. Read why say that now.
1 to 13.
1 to 13. Read I just said. MCQ 10 marks.
From which chapter?
That no need, sir. We will just
If you make only from same, your grade also you have to submit. Now you have to prepare the question. You have
sir,
to
then
prepare.
you give grade.
No, I don't care now. You prepare grade and give. Otherwise, from same chapter, go by question. From other question is gone. Remember. Okay. Structure of the diagram. It is our book.
That is 2.
Children, it is our book.
It is our, but it is two down. We are in option.
We are now. Page number.
242.
Yeah. Long question you have to draw from diagram. Okay?
Sir, we can keep some numerical. No?
Which one is so boring?
244.
Miss, which one is so boring? Hello? Making yeah. Eating food also very difficult, okay? You have to cook food. Okay, so here question number 1, 3, 4, 5. Only this chapter contains very less exercise work. Possible mistake. Alright. Question number 1.
Sir, you will not give this time to make this.
First we will discuss how many is completed.
Sir, if you say no MCQ, then the person will give this.
Yeah. MCQ now, I will not give back the one. Others only. Listen. What type of satellite is International Space Station? Geostationary orbit, right? Okay. Number B. What is global positioning system used to find an object?
Location.
Location. Find out, right? A web-based tool which helps us to
Browser.
find the information from the internet. What is that?
Search engine browser. Web-based search engine.
Search engine, right? Which of the following is an example of hacking? Cybercrime.
Sir, bully.
Hacking.
Cyber law. No, sir, no. Cyber crime, sir.
Hacking is cybercrime.
Cyber law.
Number E.
What is the
Which of the following does the computer virus to itself?
Remove.
Remove.
No,
Destroy, sorry.
Destroy. Okay.
Other.
Will you write right?
If server.
Number 3, differentiate between. Number 4, short questions. Number 5, long questions, right? Okay. Now I'm going to give you this work to you. Okay. Which group are you in? Hello, boy. Newton. Only different between.
Okay, sir.
Now who is next?
Einstein.
Einstein. Short answer ABCD. Completed? Now next one. Tesla. Tesla long questions A and B. And Edison. CND. And Hawking. ENF.
Parsimony.
Has everybody got the job or
Sir,
not?
tomorrow.
Tomorrow we have to complete it, right? Okay. Listen up. Here is comes along students. Now I will open content from government book. 9 science PDF. Does it belong to you? Hello children. Look at the whiteboard. What is there?
Sir.
Okay, MCQs are here, please. Listen. This government book, listen. Our sitting boy. Government book translated in English. Read the question. Static and revolve around above the equator. Which one is correct? Number B,
Leo. I mean,
Leo, Leo.
No, no, no.
Leo. I think so.
Geostationary orbit.
Yeah.
Geostationary orbit, eh? Number second, read the question.
Which is the similar modulation character shown in the development of radio wave frequency.
Yeah. Radio wave transference. Frequency of the broadcasted wave is more. Broadcasted waves are reflected easily from ionic layer of the atmosphere. Broadcasted waves are limited for a fixed distance. There is less effect of external environment in broadcasting. Which one is correct? Hello children, you have to do this work first. Don't copy that.
Deepak.
Which one is correct?
Class 6.
Frequency of the broadcasted wave is more. Broadcasted wave, I think frequency is more.
Deepak.
Why next? Number 3, read the question.
Frequency of the broadcasting wave.
Read the question number 3.
Which syntax is
In your copy, write down. I, B, I, A. Then I will just work it out this. I'll show you again. I. So no, you mark it and later on when I show this one, then you can write down. Okay.
Sir,
I, B,
I.
I, A.
Yes, sir.
Now question number 3. Read the question. 3, 4, 5, right?
which syntax is suitable to solve plant is so fast type.pptx. B number I think. B number sir. B. Arun can look na sir.
पछि भन्छु छोडे
He looks all everything. B and number C.
B and C. No sir, there is only one dot and it is double dot. B and C.
So will there be single dot or double
I
dot?
think single dot sir.
Single dot will be there, that's right.
B.
So number B is correct. Number D, read the question.
Electronic mail. Electronic mail.
Number?
B.
Now, number 5.
Message from social media, receive friend and feeds which are discussing them.
Digital footprint.
If it may remove some message from social media, harassing a friend and feel safe, which awareness does he lack?
Digital footprint. Because in digital footprint we get all the activity which we
Yes,
have
yes,
done.
what is that? Digital. Okay? Now next one. Why? Today this net is very slow, right? Right?
So also that
Which object? Okay, now we start with this one. This is yours. MCQ only. What do you do? Your work is MCQ only. Okay? I've already given the answer. Okay, now listen, children. Hello. Discussion you do later on, miss. Pay attention. So we are nearly at the end of this chapter. What is the chapter? Classification of elements. Now earlier it was discussed about position of elements in periodic table. Alkali metals. Group 1A metals are alkali metals. Hey, group 1A. Now here we can see it. You can see here, like lithium, sodium, potassium, rubidium, cesium, francium. These are alkali metals. 1A. Why? Their oxides are soluble in water and they can form alkali. Please don't talk now. And group 2A, this is IIA, they are called alkaline earth metals. Alkaline earth metals. Why? Because they are found in earth crust. They are found in earth crust and they also can form alkali. So I said alkali, alkali. What is alkali? Water soluble base is called alkali. Strong bases are alkalis. They are corrosive in nature. They can damage our skin. Uh, Sulfuric acid is acid. How base? How that one? Sometimes there may be jam in the toilet or in kitchen pipe, right? So to make it open, they use caustic soda or not? You said caustic soda. Caustic soda. So its chemical name is potassium hydroxide. What is this? Potassium hydroxide. So potassium, it belongs to group 1 or not? It is very strong base. So potassium hydroxide, it is found in solid form. When you mix in water, it mixes with it. And if you put in your finger, then fingers also will damage, right? Very risky. You say sulfuric acid, hydrochloric acid, they are strong acids. They are also corrosive in nature. They can damage our skin. In the same way, alkali, strong bases also can damage our skin. So alkali metals, alkaline earth metals, here elements of group 6. Elements of group 6. Which one are elements of group 6? This one. Here it is. Oxygen, sulfur, selenium, tellurium, polonium. These all are chalcogenes. What do you call them? Why are they called chalcogenes? They are found combined with copper. Combined with copper. They can form compounds with copper easily, that's why. Elements of group 7A, they are called halogens. What do you call them? Why? Because they can form salt with metal. They react with metal and form salt. For example, this is metal, this is halogen. Now what does it form? NaCl. Sodium reacts with chlorine and forms sodium chloride. Magnesium metal reacts with chlorine and forms magnesium chloride. Yes or no? These things you have to remember. And the elements which lie at the right part, or BIIA or ET or 18, they are called inert gases. What do you call them? Why? They are passive in nature. They do not take part in chemical reaction. They do not take part in chemical reaction. Now next one, you can see 1, 2, 3, 4, 5, 6, 7, 8. These are called representative elements. Group 1A, 2A, 3A, 4A, 5A, 6A, 7A and 8. They are representative elements. Means they have only one valency, no variable valency. Their salt is also colorless. Salt is colorless. But in between 2A and 3A, are here some elements or not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many groups are here? 10 groups. So these elements are called transitional elements. What do you call them? Why? While going from here to there, we must pass from here or not? Have you heard about transit? If I want to go to America, there is no direct flight from here to there. There, my plane at first may go to one place and it drops over there. Then again I have to wait for another plane and go. That is transit. Here also, while going from here to 2A to 3A, we have to pass from them or not. That's why these are called transitional elements or transitional metals. These all are metals. Now, here are two groups of elements. They lie just below the main periodic table. And these elements lie in transitional group. They are found inside the transitional group, means they are called inner transitional elements. They are found in transitional group, that's why they are called inner transitional elements. Those things you have to remember. Now, next question was there, reactivity of elements. What are there? Reactivity of metals, reactivity of non-metals. Okay. First of all, let's discuss about, and next thing, metalloids were discussed or not? Metalloids means those elements which possess the characteristics of both metals and non-metals. Especially they are found in group 4A, 5A or 6A in 3 different groups. In zigzag way, you say zigzag way. Children, here are 3 metals given, right? What are the 3 metals? Lithium, sodium, potassium. Look at the atomic structure of lithium, sodium, potassium. Metal. Now make concept clear. Metal means, do they lose electron or gain electron? Metals always lose electron and they possess what type of power? Positive power. All metals they possess positive power. But when we talk about non-metals, they gain electron and they possess negative power. So, becomes positively charged by losing electron, by donating others, and possesses negative charge by gaining electrons. Now, lithium, sodium, potassium, they all belong to which group? 1A. Whose atomic size is smallest? Lithium. Which is atomic size is largest? Okay. Among these 3, which is more reactive and which is less reactive? Which is the most reactive? Which is the least reactive? What do you think? Which one is most reactive and which one is least reactive?
Potassium is more reactive.
Potassium is most reactive. Why potassium is more reactive? Here we have to know nuclear force. What to know? What is nuclear force? The force of attraction due to which nucleus attracts the electron towards its center. This nucleus attracts the electrons with more force or this electron? What do you have? Small atoms, nuclear force is more, or big atoms, nuclear force is more? What do you think? Small or big? Remember, we know force, nuclear force or force whatever say, that is directly proportional to Gm1, M2, inversely proportional to distance. If distance increases, nuclear force decreases. That means which atom has maximum nuclear force? Small one. Which has more? So which one can lose electron faster? With more nuclear force or less nuclear force?
Yes.
If less, then it attracts, no?
More than it.
Sorry, less nuclear force means it cannot attract. That's why here is less nuclear force, it can lose electron faster. It has more nuclear force, it cannot, metals they do not gain, they always lose. But among these 3, which one can lose faster? Potassium, because nuclear force is weaker. Here nuclear force is stronger. Here nucleus is much more stronger. Suppose, if I show you next one, just remember, metals means when the atomic size increases, reactivity also increases. Here is beryllium, magnesium, calcium. Let's take 3. How many are taken? Beryllium, magnesium, calcium. Whose atomic size is largest? As the atomic number increases, atomic size also increases. So, among these 3, which is more reactive? Beryllium, magnesium, calcium. Which is more reactive? Here make concept clear. Whose atomic size is bigger? Calcium. Atomic size is bigger. That is metal. It is more reactive. Atomic size is smaller. That is metal. That is less reactive. Got the idea? For metals, what to remember? Atomic size. Bigger atomic size, more reactive. Weaker means smaller atomic size, less reactive. Why bigger is more reactive? Because it can lose electron faster. can lose electron faster. Okay. Now again you have to remember, in between sodium and magnesium, which is more reactive? But when you go from left to right, atomic size decreases. Atomic size decreases. So sodium is more reactive. Magnesium gayab. Magnesium is less reactive. If so, metals in group reactivity increases. In period reactivity decreases. Increases, decreases, and what is the word? Don't say like that. Metals means they lose electrons. Bigger atom loses faster, smaller loses slower. Bigger atom is more reactive, smaller is less. That concept must be made clear. That's why what the teacher is saying. You have to develop the concept over there and say, what are you doing here, Miss Buddha? Miss Buddha. Listen. Metals lose electron. Bigger atom can lose faster. Smaller atom can lose slower. Bigger is more reactive. Smaller is less reactive. If so, in between boron and aluminium, which is more reactive, which is less reactive? Between boron and aluminium. Aluminium is more reactive. Why?
Because they are same group, sir.
They lie in same group. They are metals. Atomic size of aluminium is more. It can lose electron faster. Is it okay? So that is reactivity of metals. That's why potassium is more reactive than sodium. Potassium is more reactive than sodium. Sodium is more active than lithium. Is it okay? Now, in case of non-metals, what do you know? Non-metals. Are we not okay? Non-metals. What do they do? They gain electron or lose electron. Gaining means smaller can gain faster or bigger can gain faster. Smaller can gain faster, isn't it? Remember, eh? While losing, bigger can lose faster. While gaining, so here are three non-metals. What are they? Fluorine, chlorine, bromine. Whose atomic size is largest? Bromine atomic size is largest. Which is smallest? Fluorine. So which is the most reactive? Fluorine, chlorine, bromine. Which is most reactive? Which is? Fluorine is highly reactive. Which is less reactive? Bromine. Why? Atomic size of fluorine is smaller. It can gain electron faster. Atomic size of bromine is bigger. It cannot gain electron faster. So make concept clear. Eh? Metals. Bigger atom can lose faster. Bigger atom is more reactive. Non-metals. Smaller atom can gain electron faster. And smaller atom is more reactive. That's it. Very simple is there, right? Remember, eh? Yeah. So non-metals, this one. Now, next person who is going to present is Joy. Okay, Joy. Let's welcome him. What are you going to say? Sonia, what are you doing? You taking out money and counting or what? Give it 1,000 to count it.
Everyone, I am going to present presentation on the topic of classification of elements.
Yeah, you look like that. You look like
Reactivity of metal. The element of group 15 and 16 and 17 are non-metals. As we move from top to bottom in a line of group of non-metals, the atomic size increases. With the addition of the number of cells and the force of attraction between the nucleus and valence shell decreases. The force of attraction between the nucleus and valence electron of a smaller atom is more than that of the bigger atoms. Due to this, smaller atoms can gain valence electrons more easily with more force attraction than the bigger ones. So the elements of group 15, 16 and 17 are non-metals, and the atomic size increases with addition of numbers of cells. The force of attraction between nucleus and valence shell decreases. The force of attraction between the nucleus and valence electron of a smaller atoms is more than that of bigger atom. So due to this, smaller atoms can gain more valence electron, and they can also be more reactive. Why is fluorine more reactive than the chlorine? Okay. Both fluorine and chlorine are non-metals and they belong to group 17 of the periodic table. The reactivity of element of this group decreases as we go from top to bottom. This is because of the atomic size of fluorine is smaller than that of chlorine, due to which force of attraction between the nucleus and valence electron is more in fluorine, and it can gain one electron more easily than the chlorine. Hence, the fluorine is more reactive than chlorine. So we know the atomic size of fluorine is smaller than chlorine, because of which it can gain one electron more faster and easier, thus which makes fluorine more reactive than chlorine. Subcells. We have learned that electrons is an atom. Electron that an electron is an atom is. We have learned that an electron is an atom is categorized by a set of 4 quantum numbers and the principal quantum numbers, and defines the main energy level known as shells. The atom having 2 electrons in its valence shell, only one orbit, is called duplet. Example, helium. The atoms which contain 8 electrons in its valence shell is called octet. Example, neon, argon and krypton, etc. The maximum number of electrons in each subcells is given below. So we know if there are 2 valence electrons in an atom, then we can call it a duplet. Example, helium. Helium have 2 valence electrons in its shell. Similarly, when it contains 8 electrons in its valence shell, then it is called octet. Example, neon and argon, etc. You can see in figure. The S cell has got maximum 2 electrons, the P cell has got a maximum 6 electrons, and the D subcell has got maximum 10 electrons. The F subcells has got 15. The region around nucleus where the probability of finding an electron is maximum is called subcell. So we know an atom, electrons revolve around atom, but it is revolving it not in similar and stable place. So we can only find the probability of finding an electron. So the region where the probability of finding an electron is maximum, that is called subcell. Block of modern periodic table. The physical and chemical properties of the elements depends on the arrangement of electrons in the subcell. According to arrangement of electrons in the subcells, the elements in the periodic table are divided into 4 blocks. They are called S block, P block, and D block, and F block. So the physical and chemical property of elements depends on its arrangement of electrons, means how the electrons are arranged in its subcell, and according to this we can divide it into four blocks. They are S, P, D and F block. S block element. The S block element includes hydrogen, helium, lithium, beryllium, sodium, magnesium, potassium, calcium, rubidium, strontium, cesium, barium, and francium and radium. The periodic table shows exactly where these elements are within the S block. Now P block element. Consequently, there are 6 groups of P block element. In the periodic table, numbering from 13 to 18, boron, carbon, nitrogen, oxygen, fluorine, and lithium lead the group. Their valence shell electronic configuration is NH2 NP1-6, except for helium. The inner core of electronic configuration may, however, differ. So there are 6 groups in the P block element which range from 13 to 18, and boron, nitrogen, etc. are head of the groups. And the inner cone of electronic configuration may differ. So they might not be same, they differ from element. D block element. D block elements are the most commonly known as the transitional metals. These elements fall between the group numbers of 3 and group number 12 on the periodic table and extend 4 rows downward. With 10 columns and 4 rows of the periodic table located in the D block, that makes for a total of 14 elements in this group. So D group elements are also known as transition metals. These elements fall under the group of 3 and 12 numbers on periodic table, and there are total of 14 elements in this group. F block element. Lanthanides and actinides are the F block elements, also known as inner transition elements. The 28 elements within atomic number 58 to 71 and 90 to 103 are referred as collectively as F block elements. So lanthanides and actinides are the F block elements. They are also known as inner transition elements, and there are 20 elements within the atomic number 58 to 71. So in book there is below the periodic table there are given the elements between 50 and 71 is missing, that are placed downwards, and between 90 to 31 are also placed downwards, which are lanthanides and actinides. Difference between S block and P block element. S block element. The S block elements have subcells as subcells as the last orbital. The P block element have P subcell as the last orbital. S block element. They can have only 1 or 2 electric in the last subcell. P block element. They can have 1 to 6 electrons in the last subcell. S block element. The chemical reactivity of element increases while going downward in a group. The chemical reactivity of electron decreases while going downwards in a group.
Elements, that is the question.
Thank you.
Thank you very much. So, credit goes to Srijal also. Actually, this is prepared by Srijal, presented by Joy, and members are Ritika and Susmita. So, isn't it Susmita?
Yes.
Susmita. So, it is a group work. So, if all the group members become active, it is possible to do the work on time. Because coming Friday again there is a program. Mini science exhibition is there. I don't know how many people are going to do. Which duty is there? Certainly your group? Many means who are the members? Or you four already prepared? Mendeleev has not done this time, right? Just remember. Okay, children. So do your sword. Um, okay, children. Reactivity of non-metals we discussed earlier. So here you must remember whether that is metal or non-metal. If it is non-metal, bigger atom has low reactivity, smaller atom has high reactivity. Finished. Next one is, it was said, which is more reactive? Fluorine is more reactive than chlorine. Why is fluorine more reactive than chlorine? Atomic size of fluorine is smaller. It is a non-metal. It can gain electron faster. That's why more reactive. You must make concept clear like that, Andrew. Understood or not? So while explaining also, you should not just go through that line by line. Now soft cells. What do we discuss? Soft cells. Okay, children. Earlier we have discussed about atomic structure. The central part is called nucleus. Nucleus contains proton and neutron. And outside, what is this? These are called orbits. Orbits contain electron. Orbit contain what call electrons, right? But when the atoms were studied with the help of electron microscope or powerful microscope can show the structure of atom also. It showed that there were no round structures. In this also there were many more. I mean, look at here. This is nucleus. See? Such type of elliptical paths were there, which contain what contain? It means elliptical paths where there is more probability of getting electron. That is called soft cell. Earlier we learned cell. What are the examples of cell? K, L, M, N, M, K, L, M, N, O, P. They are also called energy level. But scientists found that there are not only K, L, M, N, O, P. There are many more. And they termed it as, especially soft cell, there are 4 soft cells. How many? 4. What are the 4 soft cells? Power Ranger, SPDF. Have you watched that one program earlier or not? Earlier it has become Power Ranger. Power Ranger SPD. SPED, speed was there, right? So Power Ranger, SPDF. So how many soft cells are there? 4. S, P, D, F. Remember, S, P, D, F. But when we talk about those SPDF, now K cell, L cell, M cell, N cell, O cell, P cell, Q cell. Sorry? No, let it be, no problem. I have mentioned here these cells, but what type of soft cells do they contain? Do all these cells contain, or which contain same subcells or different? So K cell contains only one subcell. What is name? S. K has got only S, right? L has got 2. What is that? M has got 3. SPD. Okay, SPD. N has got 4. M. O has got 4. P has got 3. Q has got 2. Learn this one. What is that? K. These are the energy levels. Energy levels mean the region where there is probability of getting electrons more. Right? So K cell contains only one orbital. What is that? S. So we can write 1s. L contains how many? 2. What are they? 1s. No. 2s, 2p. 2s, 2p, right? M contains 3s, 3p, 3d. N contains 4s, 4p, 4d, 4f. O contains 4. 5s, 5p, 5d, 5f. P contains 3. 6s, 6p, 6d. Q contains 7s, 7p. Why did I mark like this? Later on, when we discuss about those electronic configuration, it will be very easy. Now, on the basis of these 4 subcells, 118 elements are divided into 4 blocks. How many blocks? What are the 4 blocks? S block elements, P block elements, D block elements, F block elements. Right? What is it? S block, P block, D block, F block. Now, what is that S block? What is P block? Make concept clear. In S block element, do you know valence electron? Outermost orbit electron present in outermost orbit is called valence. So, in S block, the outermost subshell is S. P block outermost subshell is P. D block outermost is D. F block outermost is F. Oh, what did Sir say? What did Sir say? It became difficult, right? Now I will show you next one. Hey. So now look at here. I think he forgot to show this one. Main cell and subcells. It is here also, right? Did he show? But he didn't explain. Yeah. K cell contains 1 subcell. L contains 2. What are they? S and P. M contains 3. S, P, D. N contains O contains P contains Q contains, right? Now, 4 blocks. What are the 4 blocks? S, P, D, F. Okay. Before that, electron holding capacity of SPDF. How many electrons can be kept maximum in S, P, D, and F? Very simple is there. In S, how many can be kept? 2. In S, we can keep maximum 2. Right? Maximum 2 only. In P, 6. 4 difference will be there. Now make concept clear. In D, how many? 10. In F, how many? 14. It shows that how many S block groups are there? 2 S block group. P block 6, D block 10, F block 14. SPDF 2, 6, 10, 14. 2, 6, 10, 14. Now children, I will show you the blocks also. Eh? What do I show you? Blocks. This go here. Again, we'll see in this one. Can you see this 1 and 2? Yes. This is S block element. The elements which belong to group 1A and 2A, these all are S block because in their outermost orbit there is S. Yes. S. Now, these all up here. What are they? P block element. How many are here? 1, 2, 3, 4, 5, 6 are there? S 2, P 6, D 10, F 14 was there, right? Now these all from here to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Now 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are F block elements. These are D block. These are P block. These are S block. Now, if I write like this, one element is like this. Say 1s2, 2s1. Which block element is it? Is it S block element? Are you sure? Because at last here is S block element. Make concept clear, right? 1s2, 2s2, 2p5. Which block element is it? Why P block? At last here is 5. 1s2, 2s2, 2p3. Which one is it? P block. 1s2, 2s2, 3p1. Which block element is it? P block. Remember, at last here is P block. Okay. 1s2, 2s2, 2p6, 3s2, 3p6, 3d4. Which block element is it? So you got the idea? At last, which letter is there? They represent same block. At last S block. At last P block. At last D block. And F block. But in this class, we have to remember mainly the electronic configuration of S block and P block only. Or some maybe there in metals D block. That is all right. Okay. Children, in S, how many electrons can be kept? 2. Maximum. In P, how many can be kept? 6. Maximum. In F, in D, how many can be kept? 10. Maximum. In F, how many can be kept? Maximum. Maximum, why did I say? Now check it here. Now one electronic configuration I am going to write. Hey, side talkers. बड़े मियाँ छोटे मियाँ talking. खाएगी पान बनारस वाले हो गए मैं तेरा दीवाना. Okay, we are discussing something. Discussing something. It comes here electronic configuration also. Please pay attention. Children, now I have written a electronic configuration, right? You have to check whether it is right or wrong. Just check only, right? 1s2, 2s2, 2p2. 1s3, 2s2, 2p2. Right or wrong?
Wrong, sir. S3 out. Maximum.
Your S3 out, it means it is wrong. Yes, right.
Maximum 2. No?
Maximum 2 only. In S, how many can we keep?
2.
More than that we cannot. Second one,
Right.
1s2, 2s2, 2p4.
Yes.
Is it right?
Right. Absolutely.
Right, eh? Good. 1s2, 2s2, 2p7.
Wrong, sir. P7. Maximum 6.
Good.
Maximum 6.
You got the idea, right? Okay. 1s2, 2s1, 2p3.
Right.
Is it right or wrong?
Right.
Is it right? But it is wrong. Let me teach you. No. But why is he coming this way? Oh, Sonny.
Oh, sir. S1 there is not.
Here is one. Yeah, here is one. Here should not be.
Yes, because the
At first, now listen, listen. At first, S must be filled, then we can go to P. At first, what to fill? S. How many should be there to fill S? 2. Then only. Because here is 1, 2S1, this is also wrong. 1S2, 2S2, 2P5.
Right, sir.
So, later on it will be very easy for you. So, while writing electronic configuration, right? Are you downloaded? Yeah, Heisenberg, bhai, how are you? Yeah, it was downloaded.
Yes, sir.
Oh, yeah, good. Soft cells, S block elements, P block, F block, and thank you also. It's done, right? Okay, that is the end. So, while reading, you just enjoy and read. Then you can understand anything also. If you start reading with force, then you cannot do anything. You know, the children of Western countries, what do they do? When they get book, they do not leave it before completion. Just keep on reading and reading. But the people of Eastern, when they get the book, they throw it somewhere else. And they don't know the cover also. What is there? Which color cover was there? That's wrong. That's why make study fun. Like in India, I think one side is there. We make travel fun. You say we make study fun. Okay, please read up to there and make note yourself. Are you ready? Time starts now. Come on, Sijal.